Let's go through some examples. You'll notice at the top of the page here, I have the general formula that is provided on your formula sheet. Y equals e to the x, dy dx equals e to the x. As previously stated, it doesn't look exactly like that. It says the derivative of e to the x with respect to x equals e to the x. So that's what's on your formula sheet. Then you have what we can call the shortcut, which is if we have y equals e to the f of x, so the function of x, the derivative is going to be exactly e to the f of x, just like previously, but we need to multiply it by the derivative of that power. If that's not on your formula sheet, if you don't remember it, you just need to use your chain rule. So let's go through and differentiate. It says determine the derivative of the following with respect to x. First of all, I'm going to start by letting y equal e to the 8x. I'm going to use the shortcut, so dy dx equals, write the same thing, then multiply by the derivative of the power, which is 8. So it's 8e to the 8x. Next, let y equal 3e to the negative 0.5x. So now dy dx equals, write exactly what you have and then multiply by the derivative of the power. Right, so 3 times negative 0.5. I hate the fact that this is a decimal, but I am going to deal with it. That would be negative 1.5 e to the negative 0.5x. You are not going to have your power as a decimal and a fraction as your coefficient. Keep it consistent. You are better off leaving them both as decimals. Next, let y equal 1 over e to the 2x plus e to the x. Now we can't have that fraction, so we're going to bring that power up and make it negative. And now we can differentiate. I'm going to move that derivative over. I'm not going to fit it. dy dx equals, differentiate each one. So e to the negative 2x multiplied by the derivative of the power is negative 2. Plus, and the derivative of ex is just e to the x. Neaten it up, negative 2 e to the negative 2x plus e to the x. Next one, let y equal e to the 2x plus 1, dy dx, rewrite it, and then multiply by the derivative of the power, which is 2. So it's 2e to the 2x plus 1. Next, y equals 5e to the 6x to the 7 minus 5x squared plus 2. dy dx, rewrite what you have. Then multiply by the derivative of the power, 42x to the 6 minus 10x. And then neaten that up, 5. I'm going to bring that derivative out the front. Now, if you look at inside this bracket, you have a 42 and a 10, so that has a common factor of 2. You also have x to the 6 and x, so you have a common factor of x. I'm going to factorize that. I could do it in one step. I'm going to try and do it. I'm going to do it in 2 so you can follow. So I'm firstly just going to factorize that bracket. So I'm bringing 2x out, and I'm left with 21x to the 5 minus 5, e to the 6, x to the 7 minus 5x squared plus 2, and that becomes 10x, 21x to the 5 minus 5, e to the 6, x to the 7 minus 5x squared plus 2. Now, the next one, you could think, oh, that's product rule. But there is a quicker way of doing it. If you just expand your brackets, you have e to the 2x. Remembering e to the x multiplied by e to the x, base is the same, add your powers, e to the x plus x, which is e to the 2x. Okay? So you got e to the 2x minus 3e to the x. So to differentiate each of them. So e to the 2x multiplied by the derivative of the power is 2 minus 3 e to the x, and the power is 1. So that's the same. So we've got 2e to the 2x minus 3e to the x. Could you factorize it so it looks the same as what you were given in the beginning? Well, you could. E to the x out the front, 2e to the x minus 3. Okay, next one. You could think of it like quotient rule, or is there an easier way? Yes, split the fraction. E to the 3x over e to the x minus 2e to the negative x over e to the x. When we're dividing indices, we subtract the powers. So 3x minus x is 2x minus 2e. Negative x take x is negative 2x. Now I can differentiate. So I've got e to the 2x multiplied by 2 minus 2e to the negative 2x multiplied by negative 2. That becomes 2e to the 2x. Negative 2 multiplied by negative 2 is positive 4e to the negative 2x. Could you put it back in the same form? You could. I'm going to do it in a different color. Probably should do that there. If you go to e to the 2x plus 4 over e to the 2x, you could then get that common denominator of e to the 2x. Now that makes sense because in your quotient rule, you have v squared on the bottom. So e to the x all squared, v would have been e to the x. There's your v squared. Okay, so remembering this would have been over 1. So from here to here, I've multiplied by e to the 2x. So I have to go e to the 2x multiplied by e to the 2x becomes 2e. 2x plus 2x is 4x. You don't need to do that if you understand it, okay? Just showing it for those that may struggle. Could you factorize that? Well, you do have that common denominator at the top, 2e to the 4x plus 2 all over e to the 2x. Okay, so if you're given a question that says no need to simplify, you could stop at that step there. If it says to fully simplify, then you probably should go with the extra steps. Again, remember you're going to have questions that say show that the derivative is this, and that might look a little bit different, and you might need those extra steps to show that. So it is important to be able to do those extra steps if required. Last example, determine the equation of the tangent to the curve y equals e to the 2x plus 4 at the point 0, 4. So we've just got one extra step. I'm also going to take note here, 0, 5, that is the y-intercept, which is going to save me time because that means c is equal to 5. So I have y equals e to the 2x plus 4. dy dx equals e to the 2x multiplied by 2, so 2e to the 2x. At x equals 0, dy dx equals 2e to the 2 times 0, so 2e to the 0, e to the 0 is 1, so that's 2. So that means my m equals 2. My tangent y equals mx plus c, y equals 2x, and because I mentioned it at the beginning with the 0.05, realizing that that was my y-intercept, I'm just writing it here. So c is 5. I can plug that straight in. So therefore, equation of the tangent is y equals 2x plus 5. Now, I recommend watching my next video, which is going to go through how to use your calculator to find the equation of the tangent. Now, we haven't covered that before, but it could have many, many applications, even in easier questions we've done before now. I have provided a screenshot here and the steps, so you might want to try and do those steps and then watch the video if you struggle with it. But you can see that in the screenshot, that was the equation we had, and there is the tangent at the point 0, 4. Now, I could have added a point to show that. I just skipped a step. So watch the next video.